Oh my gosh, wait. Hello, welcome to How to Do Factoring Binomials, also known as the reverse of foiling, which is also known as expanding. I'm sorry if I sound a little bit congested. I don't know if I really will sound congested to you, but I am because I have allergies and it's spring. Anyway, let's get on with it. First, we're going to start with a sample equation, and here's our sample equation. X squared minus 6x plus 9 is equal to 0. What we're basically trying to do here, what we're saying is if you take x squared minus 6x plus 9, you set that equal to y, and then you graph that, right? And it's probably going to be parabola because it's a quadratic equation, meaning that the highest power in the equation is a 2. If you do that, and then you find where on the line y is equal to 0, what is the x at that point or those points. And so to figure out how to do this, we're going to need to go back to some stuff about foiling. And I did make a video on foiling, and it might be useful to watch that if you need some reminders on that, but we're going to do a little bit of reminding here. So basically, what we want to get to is something that looks kind of like this. What happens is that when you foil, you take these and you multiply it out. It's also called expanding. By the way, fun tip, I don't think you ever call it foiling when it's 3 of these little things in parentheses, because foiling is specifically for 2 of them, but you take that and you multiply it all out and you get this. How that works is you multiply ax by bx to get abx squared, and then you multiply ax times h to get axh, and bx times k to get bkx, and you also add those together, and usually that ends up being one little term because it adds together, assuming that you know all of these letters, because they should all be constants, meaning that they are not variables like x that change. They're all just numbers like 2 or 5, and they don't change. If you know all of them, then this will simplify down a lot. So it could be something like 5x or something, right? It'll be a lot simpler than that. And then for the final term, multiply k and h together. So we go back to our sample equation, and first we want to look at the x squared because I want to talk about something. X squared, you notice, doesn't have any numbers in front of it. So where did the AB go? Because the AB were the coefficient of the x squared, right? So where did it go? Well, here's the thing. In this equation, a and b multiply together to make 1 because they are both 1, and so we just don't write them because when you multiply something by 1, it's just itself. It doesn't equal anything different, so we just don't write it down because it doesn't add much. To make things a little easier, we're going to simplify this expression. Really what we're doing is changing all the a's and b's to 1s, and then it just looks like this, because you're just multiplying all those things by 1s, and that doesn't change their value, so you just don't write the 1s. And we return to our equation, and now I want to talk about the 9. Put it in pink so it stands out. What we want to do 9, when we know that the 9 is 2 things multiplied together, right? So we want to figure out all the ways we can get 9 by multiplying 2 numbers together, 2 whole numbers, because if they aren't whole numbers, then you've got to use the quadratic equation, and it's a little bit of a pain. So we're not really going to talk about it right now. So all the things you can use to get 9, right? And those are 1 times 9 and 3 times 3, and you can't mix and match them because it's 1 times 3 is not 9, and 3 times 9 is also not 9. So you've got to keep them together, right? But here's the thing. Those are not the only ways we can get a positive 9, because when you multiply 2 negative numbers together, you also get a positive number. So we got to add the same things, but both are negative. So we've got all our sets of numbers here. Then we want to look at the 6, and remember it's negative, and the fact that it's negative is going to be really important, so we can make that in blue like the 6 is. So here's the thing. These numbers that we have for 9 are k's and h's, right? Potential k's and h's, because they're the things that you multiply together to get a 9, which are also the things that you multiply together to get this negative 6, right? Because this term is k times one of the x's plus h times the other x. So we need to see which of these sets of a k and an h can be added together to get negative 6. So we put them all down here with plus signs instead of multiplication, and we try them all out, and it's got to be -3 plus -3. What are we going to do with this? Well, we'll go back here and remember that the a and the b are 1s, so we're not going to pay attention to them. We're going to get rid of them. We don't really know what to do with the x right now. We don't have anything that can help us with that, but we do have something to do with the k's and h's. Remember we were just talking about how we could find those? So we're going to take those, and then we go back here, remember, right? And look, there's our k, there's our h. And it doesn't matter what order we put them in, it doesn't matter which is k and which is h. First of all, because they're the same number here, and second of all, because there are no a's and b's that would impact them. But it doesn't really matter which order these numbers go in, because the a, b sort of thing isn't going to change them. Right? So we don't need to worry about it. So basically just like don't worry about the order they go in right here. So we put those in, and we can make this a little bit easier to read, right? Plus -3 is the same thing as -3, so like write it like that, you know, right? Make it a little easier. And then, oh no, wait, we can't forget. This thing was not originally an expression. It's written as an expression right now, meaning it doesn't have an equal sign. Expression doesn't have an equal sign. This doesn't have an equal sign, but it's supposed to have an equal sign. It's an equation. So we gotta add that back in and unhighlight the 3's because we don't really need to pay them special attention anymore. So we've got x minus 3 times x minus 3 equals 0. How are we gonna use this to find what x equals? Well, here it is. This is going to make it so much easier for you in the long run. Guess and check works too, but it's a lot better than the guess and check because guess and check can take a real long time sometimes. So what we're going to do is we're going to take the contents of one of these sets of parentheses. We would take both, but they're the same, so it's not going to change. So we'll only take one of them, and it'll apply for both. We're going to take it, we're going to write it, and set it equal to 0. And then we're going to solve that. And that's x equals 3 in this situation. And why this is because if this is 0, it doesn't matter what this is, because anything times 0 is equal to 0. Now this is 0, and this is also 0, and 0 times 0 is 0, right? But this could be 5 or something, and it would still work, because 0 times 5 is 0. It's so great. It's so great. It just works really well. But remember, this only works if the equation is equal to 0, because there is no other number, you can multiply by anything and get your original number back. And now we're going to try a new example. So here we got this new example. And it looks kind of a lot harder, right? X squared plus 3x minus 20 equals 8. Like, look at that. That is not set equal to 0. That's a little worrying, because I just told you that it only works if it's equal to 0. Well, don't worry about that. That's a really easy fix. Just calls for some simple algebra. So what we're going to do is we're going to move the 8 to the other side. We're going to subtract it from both sides, and then we've got our little new equation on the one side, and then we've got a 0 on the other side. Problem solved. Wasn't hard at all, right? So I'm going to put our new equation up here. X squared plus 3x minus 28 equals 0. And now we're going to do what we did with the other one. We're going to take 28, and remember it's negative. It's important to always pay attention to what the sign is. It's going to really mess you up if you don't pay attention all the time. It's really easy to lose a lot of points on like a math test if you're not paying attention to signs. So definitely pay attention to those. Now remember, what we're going to do with this is we're going to find all the things that you can multiply together to get that. But this is negative. And how do you get a negative number by multiplying two things together? Well, one of them has to be negative and the other one has to be positive. So if you were multiplying two positive numbers together to get a positive 28, then you could multiply 1 and 28, 2 and 14, or 4 and 7. And what we need to do is write each of those little things twice, but have a different one be negative in both of them. Here we have 1 times negative 28, 2 times negative 14, and 4 times negative 7. Then we also have negative 1 times 28, and negative 2 times 14, and negative 4 times 7. And now we got to do the thing with the 3. So we got to write them all down with plus signs instead of multiplication signs and see which one adds up to be a 3. So here they all are. That's a little hard to read. Like, not that you can't, it just could be easier. So we're going to write them all again. And all of the ones on the left, the number that's being subtracted is a lot bigger than the number that's being subtracted from. So we know that none of those will work because they're all going to be negative and our number is positive. And the one that ends up working is 7 minus 4. So that means that our k and h are 7 and negative 4. And what we're going to do with those, we're going to go back to this little thing and we're not going to forget the equals 0 this time. Make sure you remember to write it as an equation. And then we're going to put the k and the h in. So we've got our 7 and our -4 in there. Then remember, why would you write plus -4 when you could just write -4? So we're going to do that. And then we're going to do the thing where you take the thing that's in the parentheses and set it equal to 0. We do need to do this with both this time because they're different. So we're going to start with the x plus 7. Set x plus 7 to 0 and then solve that. It's x minus 7. It's x equals -7, and then we're going to do with the other one. X minus 4 is 0, and then x equals 4. And remember, you always should check to make sure your solutions actually work and you didn't like mess something up. You should put it to the original equation, but I'm not going to do that. I'm just going to show you something right now. I'm just going to show you something real kind of interesting that wasn't as easy to show with the other example. So we take this, right? If we set x to -7, then -7 plus 7 is 0. And then we take the other one, and we have -7 minus 4 is -11. But 0 times -11 is 0. No problem. We do it with the 4. 4 plus 7 is 11, and 4 minus 4 is 0. But 0 times 11 is 0. There is no problem. See, that's great. I love it. And when you check your answer, remember you should put it into the original equation, not the one that you got from it, because you might have made a mistake along the way and like messed up the equation, so it's not the original equation anymore. Just remember, it only works if it's equal to 0, but you can do it. You might have to learn how to complete the square, and to be honest, I did not do well at that. I didn't understand it, but everyone else in my class understood it, so probably you'll be fine, and if you're not, you can look it up. That's what I always do every time I'm like, oh, I need to complete the square here for this to work. Hope this video has helped you. Good luck in your math endeavors. Thank you for watching. Goodbye.